Hello everyone, welcome to Network Jungles. Today we discuss about FLSM of Class C Private IP, and I hope you can saw the previous video of topic of subnetting. Let's start the FLSM for Class C Private IP. So once again we can recall the subnet table, that is the slash notations here. So there are 6 columns. So first column represents the IPv4 bits, so that is the 32. Then second column is the host portions, so it is related to how many bits in the host portions. Then third column is the network portions, so how many bits in the network portions. So these portions will be constant for the entire subnet mask. And fourth column is the submask, so it can be used to identify the how many bits in the network portions, then how many bits in the host portions. Then fifth column, here is the formula is 2 power of host portions. Then last column is the number of usable host, so that is the valid IP address for assigning the network devices. Here 32. So we already know IPv4 is the 32 bits. Here, so here is the subnet value is /30 first row. So it belongs to the network portions. So after 32, so first 30 bits are network portion, so the remaining 2 bits are host portions. So it can be represented as bits 00, 01, 10, then 11. Here is the available combination for the 2 bits 4. So number of available host, the formula is 2 power of host portion. Here is the host portion is 2, so 2 power 2 equal to 4. That is the combination. First 00 is belongs to the network address. Then last bit can be used for the broadcast address. So the valid IP address can be used for 0110. Here is the last column is the number of usable hosts. So that is belongs to the valid IP address for assigning the network devices. Next, likewise another example. So after 32, so 28 bits belongs to the network portions, then remaining 4 bits belongs to the host portions. Here is the combination of the bits in the host portion is 4, so it can be starting from 4 zeros, 000, 0001, 0, 0, 10, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, then 0, 1, 1. Again next bit value is 1000, so you can start here. Here, so number of bits is in the host portion is 4, so it is the combination of, so 2 power 4 equal to, that is 16. Here 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 8, so there is the 16 combination for the 4-bit host portions. Then here first bit belongs to the network address, Then last bits belongs to the broadcast address, and remaining portions can be used for the valid IP address. So it can be used for the network devices. So out of 16, so 2 bits are removed. So remaining 14 bits can be used for the network devices. Likewise, next, I hope you got the clarification about the how many bits in the network portions and host portions and valid IP address using the subnet value, that is the slash notations. Now we go to the fastest way. So 32. For example, slash 24. So 24 bits are used for the network portions. So 32 minus 24, 8. So it belongs to the host portions. So 2 power 8 equal to 256. So it can be reduced by 2 because 2 IP address can be used for the network address and broadcast address. So the valid IP address is 254. Here is the example 256, then 254 is the combination. Next we discuss about the FLSM of class C for the 250 host. So in the class C private IP address, so 250 host is required for the production area. So how to calculate? Here. So for example, you should record the 250 host. So you have to select the subnet, how many bits in the host portions. So you can select the 8 bits for the host portion, then 24 bits for the network portions. So that's why we get the 256 available host, then 254 is the usable host. So 2 power 8 equal to 256. So minus 2. So it goes to for network address as well as the broadcast address. So the available valid IP address range from 1 to 254. Here is the formula. So 2 power h minus 2 equal to requirement. So 2 power 8 minus 2 greater than equal to 250. That is the 250 our requirement. So 2 power 8 equal to 256 minus 2. So minus 2 goes for network address as well as the broadcast address. So 254 greater than or equal to 250. So the condition is valid. So number of host bit is required for 8. So out of 32 bits, so 8 bits are in the host portions. So remaining are network portions, that is the 24 bits. Here is the entire class C private IP address for the /24. So 192.160.0.0/24. This is the network ID. So first IP address 0.0, then starting 0.1, that is the valid IP address starting from 0.1 to 0.254. Then 0.255 is the broadcast address. Likewise 1.0. So this is the network mask /24. So /24 means the first 24 bits are in the network portions. Remaining last 8 bits portions are host portions. We already discussed how to convert the binary bits to decimal conversion in the previous video. So 1.0 is the network address, 1.1 valid IP address starting from 2, 1.254, then 1.255 is the broadcast address. Likewise, the last class C private IP address 192.160.258.0/24 to 192.160.255.0, that is the network address. .1 is the valid IP address starting from 2.254. Then 192.160.258.258 is the last broadcast of class C private IP. So our next requirement is the 60 host IP address. So this is the formula to calculate the how many bits in the host portions, then how many bits in the network portions. So 2 power of h minus 2 greater than or equal to requirement. So our requirement is the 60. For example, we have to take the host bit is 5. So 2 power 5 minus 2. So 2 power of 5 equal to 32. So 32 minus 2, 30. So the condition is not valid. So we only get the 30 valid IP address in the host machines. So for the 5 bits. In case. So next we take the six bits in the host portions. So 2 power 6 minus 2. So 2 power of 6 equal to 64 minus 2. So we get the 62 valid IP address for the network segments. So the condition is valid. So we have to choose the 6 bits in the network portions. So out of 32 bits, so 6 bits in the host portions, so remaining bits in the network portions. So here we use the /26. So 2 power 6 equal to 64. We get the 62 valid IP address here. So 60 hosts is required for our production area. So based on the formula 2 power h minus 2 greater than or equal to requirement here. So 2 power 6, that is the 6 bits in the host portion, then remaining bits in the network portions. So n equal to 26, then h equal to 6. So totally 32 bits. Next. So how to calculate the network address, broadcast address, then for the different subnets. Let's take the paint. So I can explain easily how to calculate the classify the different subnets. So for example, you have to draw the straight line. So in IPv4 is the 32 bits. We already know. Here is the record bits in the host portion is 6. So that is the 2 power 6. So 64 bits. So in each portion contains the 8 bits. So 32 bits can be divided into the 4 portions, 8 bit, 8 bit, 8 bit, then 8 bit. So we record only the 6 bits in the host portions. So 8 plus 6, 8 plus 8, 16. So 16 plus 8, 24. So here only record the 2 bits. So 26 bits in the network portions, last 6 bits in the host portions. So starting from 0, ending with 255. So 2 power 8 equal to 256. So here, so 256 divided by 64. So how many subnets we can get? That is the 4 subnets. You can divide the 256 divided by 64. You can get the 4 subnets. So you can divide the 4 portions, 1, 2, 3. So 64. So 64 plus 64, 128. 128 plus 64, 192. 192 plus 64, that is the 256. That is the last IP address. Then valid IP address. So as well as we can write the 0, 64, 128, 192. It is the network address. Next we write the broadcast address. So 64, before the 64, the last value is 63. So I can write the different color, 63. 63, 127, 191, then 255. It is the last valid bit in the last IP address in each sequence. Then this is the valid IP address. So 1 to 62. Then 65 to 126. 129 to 190. 193 to 254. So this way you have to calculate the different subnet for the valid IP address and the network mask and broadcast address. Here. So 256 can be divided in the 4 portions. In each portion contains the 62 valid IP address. So first you have to write the 0, 64, 0, 64, 128, then 192. So this is the network address. Then how to write the broadcast address? So before the 64, the last bit value is 63. Then 128. So before the value is 127. Likewise 192. So the last value is here 191. Sorry. Then here 255. So 63, 127, then 191, then 255 is the broadcast address. Like this, 1 to 62. So it is starting from 1 to 62, then 65 to 126, then 129 to 190, then 193 to 254. So this is the valid IP address for the host machines. Subnet table here. So the value is /20. So here is the 60 host valid IP address. So how to calculate the submask for the /26? Here. So out of 32 bits, so 26 bits in the network portions, then 6 bits in the host portions. So 26 bits in the network portions, then 6 bits in the host portions. You can write the 1, 1, 1, 1, 1. So that is the 8 ones. Because IPv4 can be divided into the 4 portions. In each portion contains the 8 bits. Here. So out of 32 bits, so 26 bits in the network portions, 6 bits in the host portions. So the summation of all the values becomes 255 dot 255 dot 255. Here the final value is 128 plus 64. So 128 plus 64 dot the value becomes 192 and remaining bits are 0. So anything multiplied by 0, so the total value is 0. So this is the subnet for /26. So 250.250.250.192 here. So /26. So the 26 bits in the host portions, so remaining 6 bits in the network portions. Already we discussed. So 192.160.0.0. So that is the network address. Then dot 1. That is the valid IP address starting from 1 to 62. So 1 to 62 means then 62 bits in the host portions. That is the we can assign the network devices. Then 63 is the broadcast address. Likewise 64. Then you can add the 0 plus 64, 64, 64 plus 64, 128. So 128 plus 64, 192. So it is the easiest way to calculate the subnet to adaptive. Then 64, 128, 192 is the network ID. Then 1 to 62, that is the valid IP address. Likewise, for the network ID 64 means then valid IP address starting from 65 to 126. Then 127 is the broadcast address. Then 128 is the network address. Then 129 to 190 is the valid IP address. Likewise. So for the class C sub private IP, so segment from 192.160./16. So it can be divided into the fixed length subnetting. So that is the /26 for the entire structure. So the last valid IP address for the class C private IP 192.160.250.192/26. Then 193 and 254 is the last valid IP address. Then this is one is the last broadcast address. So here another example is the 30 host. So we need the 30 host for the protection area. We can take the formula 2 power h minus 2 greater than or equal to requirement. Our requirement is the 30 valid IP address for the protection area. So 2 power h. So h is the host bit in the network segments. So we can take the 5. So 2 power 5 minus 2 greater than or equal to 30. So 2 power 5 equal to 32. 32 minus 2, 30. So the 30 greater than or equal to 30. So that is the valid conditions. So we can take the 5 bits in the host portion, then 32. Out of 32 bits, so 5 bits in the host portion, so remaining 27 bits in the network portions. That is the /27 subnet for the 30 valid IP address. Next, here. So 256 can be divided into divided by 32. You can get the value 8. So 256 divided by 32 is equal to 8. We can get the 8 network segments for the single subnet. So you can write, for example, you have to take in the line. So you can divide into the 8 portions. 1, 2, 3, 4, 5, 6, 7. So you can write 0. So 32. So 32 plus 32, 64. So 64 plus 32, 96. 96 plus 32, 128. 128 plus 32, 160. 160 plus 32, 192. Then 192 plus 32, 224. So this is the network address. So 0, 32, 64, 96, like this, 128, 160, 192, then 224. So next we can write the broadcast address. So before the 32, so the last valid IP address is 31. Likewise 63, 95, 127, 159, 191, then 223, then last valid IP address is the 255, 0 to 255. So this is the broadcast address for the different network segments. So 63, 95, 127, then 159, 191, 223, then 255. Next, so between the range we can use the valid IP address for the different segments. So 1 to 30. So here 1 to 30. So that is the 30 valid IP address. So 33 to 62, then 65 to 94, then 97 to 126. Likewise 129 to 158, 161 to 190, 193 to 222, here 225 to 254. So out of 256 you can divide the 64 bits, means you can get the 4 portions, or 30 to 30 host means you can get the 8 portions, 8 network segment in the FLSM class C. Here /27. So the required host valid IP address is the 30. Here is the subnet mask is the 250.250.250.224. So /27 is the, it can represent the 27 bits in the network portions, then remaining 5 bits in the host portions. So 0, 32, 64, 96, 128, 160, 192, 224 is the network address. Then this also represent the network address. Then last address. So 31. Here is 32. Then 63. Then 64. So 31, 63, 95, 127, 159, 191, 223, 255 is the broadcast address. Then valid IP address. So between the range. So 0, 31. So between the range 1 to 30, then 32, 63. So between the range 33 to 62, 64, then 95, 65 to 94. Likewise 97, 126. So 225 to 254. So that is the valid IP address for the entire class C private IP address. So that is the last valid network segments is the 192.168.258.224 for the /27 segment. So 2225 is the valid IP address starting from 254 is the last valid IP address. Then this one is the broadcast address. Yeah, thank you. I hope this video is useful for you. Thanks for watching video. Click the bell button to subscribe. Let's see a next jungle video for the FLSM class B.